complete plot. So click OK, and we have this output. So here is the analysis result. Among all the indicators, and you need to interpret coefficient, p-value, and R-square. Okay? So let's start with R-square. So R-square is 0.08, or kind of 9%. So how you interpret the R-square? You can view the video. So I can briefly introduce here. So R-square represents the degree your model can explain the variance of the outcome. So you see the price increase, decrease, and showing the variance. And you build this regression model and try to predict or analyze the trend of the price. And then given our R-square just 0.09, so that means our model can only explain 9% variance of our outcomes. So we don't have a really reliable model, but it's understandable. So we are analyzing energy price. And you know, for energy price, for stock price, and there are so many environmental factors. For example, inflation, for example, labor cost, interest rate, so and so. So it's very likely we won't have a really, good model and have really high R-square. So here is fact. Our model can only explain 9% of variance of outcomes. And then let's look at coefficient and p-value. So when we look at coefficient and p-value, and we need to start with p-value first, because the p-value will tell you so whether the association or impact of those independent variables are significant or not. So if it's not significant, and most of the time it doesn't make sense and to interpret the coefficient. So here, let's see which one is coefficient. Remember, we set the threshold 0.05. So that means any p-value less than 0.05 and will indicate the significant impact of association. So here, we see we have this one. So this one is really small. It's almost p-value almost 0. So that means 11 0 after the decimal, okay, almost 0. So this one showing percentage of hydrogen is a significant associated with the energy price. And then we can look at the coefficient, right? So we have a positive coefficient. So that is the degree change. So here means, for the percentage of hydrogen is showing in percentage. So if we look at the data, we see it's showing in percentage, and percentage of hydrogen, and it's here. We see, so actually most of them quite small, and around 1%. So that explains the coefficient. So the coefficient is with an increase of 1 unit of the independent variable, and the coefficient unit change, and we will see on the dependent variable. So here with this 172, so we can interpret, so 1%, so 1 unit change. So that means 1% change with the percentage of hydrogen output, and will result in $172 price change. So that's a lot, right? So that's a lot. But as we saw before, so the percentage of hydrogen is most time is around 1, or most time less than 1. So that can explain why we see such big coefficient. And let's go to next. So here we have another one. So that is the percent of oil. And percent of oil also have positive association with the price change. So here is 7.8. So here our interpretation can be with 1% of the change on energy output by other, and we will see $7.8 price change and in the daily price. So for all the others, and we don't see the significant impact given we set the threshold 0.05. So here for coefficient and both two variables showing the positive impact, that means the increase of the energy output of those field type and will increase the price change. And if in any case we have a negative coefficient, and that will indicate, increase of energy output with those field type actually will decrease the price change. So as you know, so price change also indicate price increase or decrease. So price change positive means the price increase from previous state, and price difference negative means price will decrease from previous state. So that's you can also interpret as price will increase, daily price will increase, or daily price will decrease. So that's the result with the R-squared coefficient and p-value. Okay, so we finished multiple regression analysis, and now remember, we're still interested in how about gas, so percentage gas. We didn't include percentage gas because gas correlated with the oil and other, remember. So in that case, we shouldn't include percent gas in multiple regression model. But we can do simple regression and to analyze its impact on association with the price change. So let's do the regression analysis, the data analysis regression. And here, our outcome Y, so M, price difference. And here, input is just the percent gas. So we have percent gas, and for those, let's see, that's our residue. Okay, also residue plot, the line fit short plot. We can also select this one, and we click OK. And here we get the result. And let's look at the R-squared coefficient and the p-value. So still, percentage of gas alone and can only explain 1% of the variance. So you can see the still power is really small. And then let's look at the p-value and the coefficient. So p-value here it's less than 0.05. So that means the association is significant. And here we have a positive coefficient. So again, so with 1% increase of energy output by gas, we will see $4 increase in the daily energy price change. Okay. So oftentimes you can create some chart and see your model performance by look at the predicted price. So here, predict price is where they use the model and based on the coefficient and predict each each day's price. So you can use the chart. So I'm going to copy paste this one and create a chart and to see the performance. So here is our prediction. Okay? So with those two, we can create some chart and to see so how's our prediction comparing to observations. Let's see this one. So this is the scatter plot. So basically, if we use the scatter plot, we can see whether this is significant trend or not. So I can add a trend line. So that means so how those prediction and correspond to the price difference of our observations. So I don't see it very clear. So the practical situation is you see a straight line. So that means whatever you predict and just fit what you observed. And ideal situation and will be like a straight line. and your prediction equal to your observation. In right here, it's never the case. So most times we see something like this. So as we see from the R-squared, so the relationship is significant. And we can expect, somehow we can expect, and with a 1% change for gas, and we will see $4 increase in the price difference. But from the R-squared, because our models, the statistical power is really low. And so that's why we can likely, the model is not very reliable. So you cannot expect, and you have a really good predictive power model, and showing, your prediction is very close to the observations. So that's why we see that kind of, scatter plot now very associated or, close to each other. So that's common. Right, so, technique-wise, I think that's all I want to cover in this session. So just make sure, as I said at the very beginning, so you can use the tool and follow my instruction or other reference to analyze data, construct your regression model. But you need to check the assumptions, right? You need to handle if there's any concern. And very important, will you get the result from Excel or other tools, make sure you need to document your data processing steps. You need to explain the method you use, regarding the regression analysis, using multiple or simple, and you handle outliers, you check the assumption for the normal distribution dependency, so and so. And then with the result, you need to interpret the result with R-squared, coefficient, and the p-values.